Full-depth reclamation is the process of pulverizing an existing asphalt roadway and reclaiming the entire section into a homogeneous granular base. This blended material can then be upgraded with an engineered asphalt emulsion to make a stabilized base. This process is commonly referred to as FDR with engineered emulsion, also known as FDR-EE. Many of our roads are under-designed for today's traffic loadings. These structurally deficient roads are no longer suitable for roadway maintenance techniques, such as chip seals, slurry seals, and thin overlays, and require total reconstruction. There are two paths an engineer can take to address this problem. One option is a total reconstruction of the road section. However, a typical remove and replace project involves removing the current section and excavating additional materials to make room for the newly designed section. The cost to remove, transport, dump, and import new roadway materials can be extremely costly. This doesn't include the possible costs associated with disruption to existing utilities, as rerouting is often required. Nor does it include user costs due to the disruption of commercial and residential traffic because of the prolonged lane closures. An alternative option can be a full-depth reclamation. The FDR process with engineered emulsion has many advantages over a typical remove and replace operation. FDR-EE can provide necessary structural improvements to the failed roadbed. This is accomplished by stabilizing the existing in-place material and upgrading their structural value. All forms of cracking are mitigated, since the entire cracking pattern is pulverized and disrupted. The granular material is then stabilized with an engineered emulsion. The recycling process provides a low environmental footprint. A 25-ton truckload of engineered emulsion can, on average, eliminate the need to remove and import up to 60 dump truckloads of material. Transportation costs are reduced, since the existing roadbed is recycled in place and not hauled in and out of the job site. Utilities are typically not affected, since the FDR process is done in the confines of the existing roadway section. The traveling public suffers little disruption since the pulverized material remains in place and does not create a long-term lane closure. The stabilized materials can then be opened to cross-traffic in less than 1 hour versus days with typical reconstruction. Significant savings of 30 to 40% have been realized by many agencies when compared to traditional reconstruction cost. With this in mind, an ideal candidate for FDR are roads that are structurally inadequate and are suffering from cracks, potholes, and loss of bonding between pavement layers. Proper site selection is an important part of having a successful project using FDR-EE. Not all materials qualify to be treated with FDR-EE. A qualified geotechnical engineer should perform a materials evaluation to determine if the road is suitable for this process. These samples can then be submitted to a qualified laboratory to develop a mixed design. A little homework can save agencies money and make sure that they are getting the very best solution.
This particular location was chosen because this is a perfect example of subgrade failure, which in this case, if we go with conventional construction, will be very expensive. Basically, we just over the years, the city, the agency, paved over desert mix. The soils engineers took samples of the existing pavement conditions, and then therefore, they decided to recommend the FDR process. Now, with this process, our intention is to have a very strong foundation for this job.
Pre-pulverization is the process of grinding up the existing road and blending all materials in the design section. A reclaimer pulverizes the existing AC section into a uniformed material with a top size of 2 inches. Pulverization is key to the FDR process and necessary for disrupting the crack patterns and sizing of the existing pavement materials. A motor grader shapes the road and prepares the road for the emulsion injection. Field inspection is an integral part of the FDR process. Here, a sample is taken to determine the in-place moisture content of the conditioned road. If the reclaimed material is too wet, it will need time to dry out to prevent a pumping subgrade. If it is too dry, water will need to be added. When using an engineered emulsion, the materials should not be over 65% of optimum moisture. The optimum moisture should be determined in the mix design. Once the moisture content has been verified to meet the design limits, then the asphalt emulsion can be added. The reclaimer is connected to an emulsion tanker that injects the emulsion through a computerized rate-controlled metering system. The typical mix design requires 4 to 5.5% asphalt emulsion by weight of blended material. Here in California City, the mix design also required 1.5% Portland cement to be spread with a cement spreader prior to the addition of the asphalt emulsion. The cement was required to achieve the retained strength requirements of the mix design. Within 30 minutes of the emulsion injection, the compaction process should begin. A pad foot roller is needed to provide the deep lift compaction. The pad foot roller will continue to roll until it reaches its maximum density and has walked out of the material. On roads with reclaimed depths greater than 8 inches, a Rex segmented roller is recommended. A motor grader will then be used to remove the pad foot marks and provide the desired roadway profile. After the road has been profiled, a 20-ton pneumatic rubber tire roller will then roll the material until a maximum density for this roller is achieved. Then a steel wheel double drum roller will finish rolling the material. An asphalt emulsion fog seal is then applied on areas that need to return to traffic in order to mitigate dust prior to the finished surface application. A sand blotter is often applied following the fog seal to prevent tracking. Once the FDR section has cured to 50% of optimum moisture content, the roadway is ready for surface application. Depending upon depth and environmental conditions, cure time typically takes from 1 to 4 days. At this point, a surface treatment such as an asphalt overlay, double chip seal, or cape seal can be applied to the road. Here in California City, a 2.5-inch overlay was applied to the road. The FDR process took 30 days to install. A typical reconstruction would have taken 90 days. The cost savings on this road because they used FDR is estimated to be approximately 30 to 40% over a typical remove and replace project. If you have any questions, please visit SaveMyRoad.com for more information.